Today we are going to learn the quotient rule of exponents, or how to simplify expressions where we divide things that have exponents with the same base. Just like we did with multiplying, I'm going to start by figuring this out by expanding it, by writing it out as a bunch of the same thing being multiplied together. So this is b to the 8th, so I'm going to write it as 8 b's being written down together. And I'd like to figure out some sort of rule so I don't have to do this every single time. Okay, and then the bottom is going to be 3 b's multiplied together. Now, because of how fractions work, when I multiply fractions, I multiply straight across the top and straight across the bottom. So this actually could look like a bunch of fractions where the first one is b over itself, and then the next one, it's multiplied times b over itself, and then b over itself, and then this would be b over like 1, and then over 1, over 1, over 1, over 1, okay? So b over itself, a number divided by itself equals 1. So for the ones where I have the same thing on top and bottom, I'm just going to cross those out because 1 multiplied times things doesn't do anything. So I don't really have to worry about those anymore. Now what I'm left with is 5 b's multiplied together over 1, which just equals b to the 5th. Now if you look at the numbers were 8 and 3. What do you think we did to get 5? If you said subtracted, you're right. So when we divide, we're going to subtract the top minus the bottom to get our final answer. What's important to remember is that while you do subtract the exponents, you should remember that as with all exponent rules, this only works if you're dividing the same base. So the letter or the number on the top and bottom has to be the same thing. If it is not the same thing, you cannot use the exponent rules. Let's go ahead and do some examples. I usually end up doing a combination of expanding and exponent rules. I don't usually use one all of the time. Let's look at number 1. Let's say you wanted to do this the easy way and get and just subtract it. Our directions say that there should be no negative or 0 exponents, so keep that in mind. So I'm going to subtract this, and I'm really tempted to say that it's 5 to the 2nd power. But let's put it top minus bottom because that's the way our division is working. 5 to the 3 minus 5 actually equals 5 to the negative 2. And our directions say, and pretty much always, you don't like negative exponents, so we want to write this as a positive. What we learned yesterday is that the positive will be that a negative exponent is the same as the reciprocal of the positive. So this is like 1 over 5 squared. And because this is a number, we should simplify. I know that 5 squared is 5 times 5, which equals 25, which gives me 1 over 25 as my final answer. Now, that can be a little tedious to do for a lot of different numbers. So what might be easier to do is to think of it kind of like you're expanding it, but to not actually write the numbers out. Just visualize in your head you have 3 5s on top and then 3 5s on bottom. And then you cancel some. Now we're left with 2 5s on bottom and a 1 on the top because 1 is part of every multiplication problem. That will give me 1 over 5 times 5, which equals 25. So instead of expanding it out and instead of subtracting it, why don't we think of it like this? After I cancel, where are the last 2 going to be left over? And then I just write the 5 squared down there where it will be. So I know that 3 will cancel, and then the bigger number is on the bottom, so I am going to put my 5 squared on the bottom. Let's use this rule on number 2. Now this one has numbers and it has variables with exponents. Fractions can be written in a different way. They can be written like this. So you can separate any pieces of the fraction. I separate the pieces that are the same. So I have the numbers together and the x's together. This way I can deal with one part at a time. And we know that at the end, because we multiply top times top and bottom times bottom, that whatever is on the top of each fraction will end up on the top of the big fraction at the end. And whatever is on the bottom of each fraction will end up on the bottom of the big fraction at the end. So let's just do each part in general. 15/3 simplifies to be it equals 5. I'm going to write it as 5/1. Then x to the 10th over x to the 6th. When I cancel out 6 factors, I'm going to have 4 left over at the end, and they're going to be on the top. So at the end, when I multiply top times top and bottom times bottom, I'll have 5x to the 4th over 1, or just 5x to the 4th. Now, you don't have to separate it out each time, but I'm letting you know that I only deal with each piece at a time. I'm dealing with the letters that are the same and the numbers that are the same. And this helps me do really, really big problems really easily. Let's look at number 3. So I'm going to look at just the x's first. Now this one's a little weird because I have a negative on the top, and then this one doesn't have a power. Remember at the beginning of every problem to write a 1 by the ones that don't have a power. This will make it less likely for you to make mistakes. So for x to the -2, I'm going to move that down like I did yesterday and put x squared up here. Then I have 2 x's and 1 more x on the bottom, which will make x cubed on the bottom. Now I can deal with my y's. My x's are done. For my y's, I have 1 y on the top and 2 y's on the bottom. So 1 y cancels from both, and I'm left with just 1 y on the bottom. You could write an exponent of 1, but it's not necessary. Now I don't have anything left on the top. Remember that these are all being multiplied together, so you could say it's being multiplied by 1. So it's a 1 left on the top. Don't put 0 there because that means that the whole thing was for naught and it all equals 0. So that is my final answer. Let's go ahead and look at number 4. I'm going to deal with each of these pieces at once. So first, 4/12. That's a fraction. And when I divide the top and bottom by 4, I get 1/3. So I'm going to put a fraction bar and then 1 on the top and 3 on the bottom. Let's look at my next piece. The c's can be divided. So 2 c's will cancel, and then what's left over will be on the bottom. And there will be 2 left over. Now let's look at the d's. So this one's a little weird because we have a negative on the bottom. I'm just going to divide these fractions. It's d to the first over d to the -2nd. Now d to the -2nd is like 1 over d squared, and that looks super ugly. But remember, this is like dividing by a fraction, which is the same as multiplying by a reciprocal. So we're going to multiply by d squared over 1 because it was 1 over d squared. And so really what this means is that we can actually just flip to the top when it's on the bottom. So I'm going to put my d squared on the top, and then it's d to the first times d to the second. And I have d cubed because 1d plus 2 more d's. And you could erase this 1 or you could keep it, either way. Let's make my fraction look a little more fractiony, shall we? There we go. Okay, let's look at 5. I'm going to deal with each piece. The hardest piece is the numbers on this one. And these ones are hard because they also have an exponent. But let's just take it piece by piece. When I look at the negatives, a negative divided by a negative is a positive. So I don't have to worry about those. It's going to be a positive answer in the end. Now there's a couple ways to do this. You could rewrite these as 10 squared, which is 100, over 20 squared, which is 400. Then simplify, and that equals 1/4. And then put in our fraction, we're going to put 1 on the top and 4 on the bottom. Another way to do it is to rewrite the bigger one as being kind of like the smaller one. So we got this one is going to be 10 times 10 on the top. 20 is equal to 2 times 10. 20 squared is going to be 2 times 10 times 2 times 10. Then cancel the common factors because they equal 1. And then we find that there's a 1 left over on the top because everything canceled on the top, and 2 times 2, which equals 4. So on this one, it's kind of equally easy to do it both ways. But if you have really big numbers being multiplied or a really big power, it might be easier to write it as factors, where you write the bigger one in a way that it can include the smaller one, so you can just cancel out those factors, and then you don't have to deal with a number like 2081 and try and think, how does that simplify what goes into it? Okay, let's do the next part. I'm going to keep my work on this one because the next one is really easy. A squared over a squared. That is the same number over itself. 2 minus 2 is 0. It's going to equal 1. This one cancels. We don't have to worry about it. Then our last one is b squared over b. You may be tempted to say it equals 2, but remember that the power on the b beneath is a 1. So there's going to be 1b left over, and it's just on the top. So now when we simplify, it is 1b over 4, which could be written as b divided by 4, or if you like this better, you could write it as 1/4 times b. Okay, let's look at our last one. Whew, it's huge. Well, let's just deal with it piece by piece. So we have our numbers. A negative divided by a positive is a negative. So I'm just going to write a big negative sign out front. I don't see any other big negatives, so our answer is going to be negative. Now let's simplify this fraction. 5 over 20 has a factor of 5 on both the top and bottom. So I'm going to divide by 5, and I get 1 over 4. So I'm going to put a 1 on the top of the fraction and a 4 on the bottom. Now let's look at our next letter. We already dealt with the numbers, so we're going to do 0 over negative 2. Now that 0, anything to the 0 power equals 1, so I'm just going to cross it out. And that w to the negative 2 will move to the top, just like we discovered earlier. So we're going to put w squared. Remember, if a negative power moves, then it's no longer negative. Now next, I have x over x. And I'm just going to move that negative down to the bottom. It becomes a positive, and it will be x5, x to the second power. So I'm going to have 7 x's on the bottom, so I'm going to write that down. Now, my next letter is y. So I have a y cubed and then a y at the bottom. And remember, if there's no number there, it's a 1. When I cancel out, I'm going to have 2 y's left over, and they're going to be on the top. Then I have z's. That top one has a power of 1. Between 6 and 1, the 6 wins, and there will be 5 left over. So that's my final answer. It looks really ugly, but we did it pretty simply. It was pretty nice. There you go.